In today's session, we have to start some next topic from chapter Wave Optics, and it is laws of reflection of plane waves using Huygens principle. Last time we already covered Huygens principle. By using Huygens principle, we have to prove laws of reflection, and after that, laws of refraction also we have to prove. So let me start this article. So first, we covered laws of reflection. The first law is the angle of incidence is equal to the angle of reflection. Means it is a relationship between angle of incidence I and angle of reflection R. And they both are equal. You can see in a diagram also. So this is incident ray, this is reflected ray, this is normal. This is angle of incidence, this is angle of reflection. Second law is incident ray, reflected ray, and the normal to the reflecting surface at a point of incidence all lie in the same plane. And simply incident ray, reflected ray, and this normal, which we shown by dotted line, they are lying in the same plane. So this is second law. Now third one, incident and reflected rays lies on opposite sides of normal. So this is incident ray and this is a reflected. Both are lying opposite side of the normal. So the meaning of means both second and third point are equivalent. Now after that, so let us first observe the phenomena of reflection using a plane wavefront. Now we are using plane wavefront and we are showing a reflection phenomena. So this is a mirror or reflecting surface XY. Now I consider two parallel rays and this wavefront AB is bounded by these parallel rays, is obliquely incident on this reflecting surface XY. You can see here, this is a plane wavefront AB and it is now incident on this reflecting surface XY. Now initially this A point reached to the mirror, but this point P still not reached to the mirror. Now here we can say that, so this point A reached to, means A dash, reached to this point. That time, the point P reached to new position B dash. Means we can say that, so distance, if I consider time to reach P to B dash is T, then this distance B to P to B dash is CT. Because you know that velocity is distance by time. So distance is velocity into time. So how much time the light ray take to travel P to B dash, same time A dash to R. So we can write here A dash R and P B dash both are same and both are equal to CT if the velocity is C, velocity of light is C and time is T. Now we draw here a line from B dash to R. Now this B dash to R line, here it make angle 90 degree. So this B dash R is a reflected wavefront, plane wavefront. Incident wavefront is here A dash P and reflected B dash R. And you know that this light ray and the wavefront both are perpendicular to each other. Now minimum condition to get this R. Now I consider here a plane wavefront AB bounded by two parallel rays obliquely incident on the mirror. Now this is angle of incidence I. Now after that, when A reaches to XY, you can see this is A reaches to this mirror XY. At point A dash, B reaches to point P and it has to cover additional distance PB dash. When A reaches to A dash, B reaches to P and this P has to cover additional distance this much PB dash to reach this mirror XY. Now in same time, in same time, means when P reached to the B dash, in same time A dash reached to R. A dash reached to R. Since the medium remains same, means here we consider this is same medium. So velocity remains same. Thus, the light cover equal distance in equal interval of time. So we can write A dash R and PB dash both are same and equal to CT. This implies that distance covered from A dash to R is equal to distance covered from P to B dash. And this distance both are same. So we can get this condition. A dash R is equal to P B dash. Both are shown by same color in a diagram. Now, since the wavefront is perpendicular to the wave norm, this angle R should be equal to 90 degrees. So from this point B dash, when we connect this R, so this angle is 90 degrees. Since we join B dash and R, we get a wavefront. And this is a reflected wavefront. So this angle is angle of reflection. This angle R is 90 degrees. Now, so this reflected wavefront, B dash R. And here we get a wavefront at later instant, A double dash, B double dash. Now, minimum condition to get this R is this angle R should be equal to 90 degrees, means this angle R. Then second one is A dash R and PB dash. Both are same because time interval is same. Consider a wavefront AB advancing obliquely towards plane XY. Again, same thing we consider. Okay. You can see here, it touch here. A dash, B dash are incident ray. A dash and B dash incident ray. So we can draw normal at the point of contact. Now, using PB dash is equal to A dash R. Draw a semicircle using a point A as the center and PB dash as a radius. Now listen, PB dash, you know that CT equal to the CT. So we consider this A as a center and we draw a semicircle with A as a center and radius equal to CT. You can see a semicircle. We get semicircle. Now after that, this angle, we have to draw this angle R, which we shown in the previous diagram also. So let I draw here tangent to this semicircle from the point B, then it touch here. Let me give the name R to that point. Then A dash to R we have to join, and this angle is 90. And this R B dash is the reflected wavefront. So this is the reflection of wavefront diagram. Now we have to draw a proof of Snell's law by using this law, reflection. Means we have to prove I and R both are same. So not the Snell's law, we have to prove laws of reflection. And first law is angle of incidence is equal to angle of reflection, that we have to prove. So let me start with the proof. So we consider this triangle. You can see this highlighted triangle, A dash R B dash. So this is a triangle. Now in that triangle, this angle R is 90 degrees. Also, we have to consider one more triangle, and it is A dash P B dash. You can see highlighted triangle. Now this is A dash P B dash. Now in that, A dash B dash is equal to B dash A dash. Now this is a common side. So you can see A dash B dash. In both the triangle, A dash B dash is a common side. Now next point, PB dash. PB dash, this one, and A dash R. Both are same, or R A dash. Why they are same? Because this is a distance traveled by light in time t. So this two distances are equal to CT. So they are equal to CT. Now after that, this angle A dash R B dash means this angle R. This angle R and another angle A dash P B dash, both are equal because so this is a plane wavefront and this is light ray. Wavefront and ray of light, they are perpendicular, so this angle is a 90 degree. Or we can say that wave normal is perpendicular to the wavefront, so this is a 90. So wavefront perpendicular to the wave normal. So here we come to the conclusion that this triangle A dash R B dash, A dash R B dash, congruent to this triangle B dash P A dash. You can see here B dash P A dash, both are congruent, or you can say congruent triangles. Then we can write here corresponding angles are equal. So corresponding angle of this angle R A dash B, R A dash B, this angle. Corresponding angle of this is P B dash A, P B dash A dash. Both angles are equal. Now here I can write R A B dash, R A dash B dash means R A dash B dash. This angle. So total this in this angle, if we add R, we get 90. R plus this angle is 90 degree because this is wave. This is normal. So here we can write this angle is equal 90 minus R. So this angle is 90 minus R. Because this is R, so this is 90 minus R. And this P B dash A. P B dash A is 90 minus this I, because this angle is I. So we can write this angle is 90 minus I. Now this 90, 90 we can cancel from both the sides. So we get minus R is equal to minus I. It means that I and R both are same. So I is equal to R. I is the angle of incidence, R is the angle of reflection, and both are equal. Here we proved the relationship between I and R, and this is a law of reflection. By diagram, we can conclude that incident ray and normal and this reflected ray lies in the same plane. The second law you can verify by using a diagram. As well as incident ray and reflected rays lies opposite side of the normal. This is also true by using a diagram. So laws of reflections are proved. Now here from diagram also you can see the second and third law. So by diagram it is already verified.